Hi everyone, this is your math guru. In this video, I'm going to show you how to express the following algebraic fraction as the sum of its partial fractions. The denominators in this case comes with repeated factors. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. In this example, we have 3x plus 1 divided by, in bracket, x minus 1 all squared, close bracket, and in another bracket multiplying x plus 2. If you look at the denominator, we see that there are three possibilities for the factors. We have x minus 1, we have x minus 1 all squared, and we have x plus 2. So writing this as the sum of its partial fractions, we have a over x minus 1, the first factor. We have plus b over the second factor, x minus 1 all squared, and the third factor, c over x plus 2. The first step is to multiply both sides of the equation by the LCD, or the lowest common denominator. The LCD in this case is equal to x minus 1 all squared, x plus 2. So multiplying both sides, we have 3x plus 1 over x minus 1 all squared, x plus 2, multiplying the LCD. And also on the right hand side, each time multiplying the LCD, we have a over x minus 1 multiplying the LCD, plus b over x minus 1 all squared multiplying the LCD, and c over x plus 2 multiplying the LCD. If we simplify, what we have is, we look for the same factors at the top and at the bottom. X minus 1 all squared, x plus 2 divides x minus 1 squared, x plus 2, that cancels. If we go to the a term, we have x minus 1, it takes out the squared we have at the top here. We have x minus 1 squared, x minus 1 squared, and on the last term, we have x plus 2, x plus 2. So rewriting our equation, on our left-hand side, we are left with 3x plus 1 equals a multiplying x plus 2 plus b multiplying, for a, we still have our x minus 1. I'm going to add that, x minus 1, x plus 2. Then for b, we have x plus 2 left. And for c, we have x minus 1 all squared. So the next step is to look for a factor of x that can eliminate either a, b, c, or a couple of those variables. So in the first case, we have if x is equal to 1. So we have if x is equal to 1. I'm using 1 because if you look at the factors, we have cases where I have x minus 1. If I put x equals to 1, it's going to make the term in this bracket 0, thus eliminating a. And likewise, if I put x equals to 1, it's going to put the term in this bracket 0, eliminating c. So that way, I'm going to get the value of b. So if I go back, I have if x equals to 1, every occurrence of x I replace with 1. On my left-hand side, I have 3 multiplying 1 plus 1 equals a in bracket 1 plus 2, 1 minus 1, plus b in bracket 1 plus 2, plus c 1 minus 1 all squared. Simplifying, I have 3 times 1, 3 plus 1, 4 is equal to a times 3 times 0 plus b in bracket 1 plus 2, that's 3, plus c in bracket 1 minus 1, 0 squared. So what happens is I have 4 equals a times 3 times 0, that's 0, plus b times 3, 3b, plus c times 0 squared, that's 0, 3b equals to 4. Therefore, the value of b equals to, I'm dividing both sides by 3, so I have b equals to 4 over 3. If I go back to my factors, the next step is, if I make the value of x, remember x can be any real number. However, I'm trying to eliminate either a, b, or c. So if I make x to be -2, that will make the content of this bracket 0, and I also make the content of this bracket 0. And what that means is I'll be able to eliminate a and b. So the next step is, if x equals to -2, I'm going to correct that. What I will have is, going back to my original equation, which is the start equation, I'm going to change all the values of x to be -2. So I have 3 in bracket -2 plus 1 equals a in bracket x plus 2, that's -2 plus 2 minus 2 minus 1 plus b in bracket -2 plus 2 plus c in bracket -2 minus 1 all squared. Simplifying, I have 3 times -2, that's -6 plus 1. I have that is -5 equals a multiplying 0, -3 plus b multiplying 0, that's -2 plus 2 plus c in bracket. I have that is -2, -1, that's -3 all squared. That will give me 9. So that's 9c. I have -5 equals a times 0, that's 0, plus 0 plus 9c. Therefore, 9c equals to -5. I'm swapping my sides. Therefore, the value of c, dividing both sides by 9, will be -5 over 9. So I've been able to get the value of b to be 4 over 3 and c -5 over 9. The next step is to find the value for a. If I use any value for a or for x, it will give me values of, or equation having b and c. And because I know the value of b and c, I can easily find a. But the option I'm going to use is what I call equating coefficient. So using the option of equating coefficient, what I'm going to do is to expand and simplify my equation. I have on the left hand side 3x plus 1. Expanding what I have on my right hand side, I have a in bracket. If I FOIL x plus 2, x minus 1, and I multiply it out, what I'm going to have is x squared plus x minus 2 close bracket. I have plus b, that remains x plus 2 and for my c, if I expand x minus 1 all squared, I'm going to have x squared minus 2x plus 1. So equating coefficients mean I'm going to write out or rewrite my right hand side having coefficients of x squared, x, and my constant. So on my left hand side, I still have my 3x plus 1 equals, for factors having x squared as coefficient, that will be my a. I have that as a, and my c. If you notice, x plus 2, which is multiplying b, does not have a coefficient of x squared. So the only factors that have that will be a plus c. Then I go to my x. So those having coefficients of x, if I check, will be, I have that as a, B, and C. So if I write that, I have A plus B and minus 2C. I'm going to explain how I got that shortly. For my constant terms, I'm taking out my highlight. For my constant term, I have that as minus 2A, I have plus 2B plus C. So basically what I've done is, if you look at this expansion, the one instead, I have 3x plus 1 equals ax squared plus ax minus 2a. Then expanding b, I have plus bx plus 2b. Then expanding the c, I have plus cx squared minus 2cx and plus c. So if I color code factors having coefficients of x squared, that would be the ones highlighted in orange. If I take factors having coefficients of x, that would be plus a, plus b, and minus 2c. And for the last one, factors constants, I have minus 2a, I have plus 2b, and plus c. So the next step is, because I'm using the method of equation coefficient, the next step will be to highlight what I have on my left hand side and on my right hand side. I'm going to start with coefficient of square. So if you look at coefficient of x squared, on my left hand side, coefficient of x squared is 0 because I only have 3 as coefficient of x and I have my constant term to be 1. So on my left hand side, I have that as 0 equals, if you look at my right hand side, the coefficient of x squared is a plus c. So I'm going to write that up, a plus c. However, we know the value of c to be minus 5 over 9. So putting that in, I have 0 equals a minus 5 over c. Therefore, a equals, taking minus 5 over c to the other side, 5 over 9, I'm correcting that. A equals positive 5 over 9. I don't need to go ahead with the coefficient of x or my constant term because now I've been able to get the value of a. I know the value of c and I know the value of b. So rewriting my partial fraction, what I will have is, on my left hand side, I have my 3x plus 1, my denominator, x minus 1 squared, x plus 2 equals, the value of a is 5 over 9, so I have 5 over 9 multiplying x minus 1, done with the first factor, plus b is 4 over 3, that is 4 over 3 multiplying x minus 1 all squared, and c, negative 5 over 9, so I change that to minus 5 over 9 multiplying x plus 2. So writing 3x plus 1 over x minus 1 all squared, x plus 2 as the sum of its partial fractions is what we have here. Thanks for watching. Bye.